So in this problem, we have a bent wire and the angle shown in the figure is 60 degrees and the intensity of the current is given 2 ampere. Now the question is, what is the net magnetic force on the wire in unit vector notation if the magnetic field is given. هلا in part A magnetic field is a dot يعني going out from the page to you. Okay, it's pointing to you. So you have to find the direction of the forces and then project them on the x and y axis. In this slide, I will focus on the direction of the force. اللي هي you have to use the right hand rule. You have to put the current on the thumb على الإصبع الكبير. Then the magnetic field on the index. You point to yourself with the index finger. And the rest of the fingers are perpendicular to I and B. So it is perpendicular to the palm of your hand. Okay? You will find the direction of F. So I repeat, the current I is on the thumb. You focus on one wire, not both. يعني مثلا let's start with F1. You put the current on the thumb going up. You point to yourself with B, and the force F, will be on the other fingers going to the right, perpendicular to the wire. Now you repeat that for the second wire, and then you project F1 and F2. هلا by chance F1 and F2 magnitudes are the same لأنه they have the same I. لأن الفورمولا هي ILB sin theta. والثeta هو الانجل between the current I and the magnetic field B. In this problem, the current is the same in the two wires, so same I. They have the same length, wires, so same L. They are in the same external magnetic field, so they have the same B. And the angle between the current and B is 90 degrees. Okay, لأنه البي هي نقطة point perpendicular to the XY plane. والI is inside the plane. أنتوا بتعرفوا من الماث إنه وقت بيكون عندي vector perpendicular to the plane, so it is perpendicular to any line in that plane. So the angle is 90 degrees, so the final magnitude is ILB. هلا you have to project this magnitude on the x-axis y-axis to find the vectors. So بده يصير في cosine و sine. You close the right triangle and you can find it. هلا the angle with the x-axis is 30 degrees. The angle with the y-axis is 60 degrees. عن يد alternate interior angles. Now to find the resultant vector in vectorial relationship, in vectorial notation, you have to add these two vectors. اللي راح يصير إنه on the x-axis they will cancel each other, but on the y-axis they will double وبتطلع الماgnitude 16. Yeah, sure. You can substitute ILB in their values and their numerical values. You will get 16 newtons vertically down. هلا in part B, no need for the calculation لأنه right hand rule راح تعطيني إنه if the B, the magnetic field is going to the right, you put the right hand rule current على thumb, the B he going to the right. So you have to do it when I am talking, you have to do it with your fingers. Use your right hand rule. So the I current is on the thumb, B is going to the right. So هلا your hand is very twisted. The other fingers are going into the page, so it is a cross. If you repeat it for the second wire, the current is going down, B is going to the right. هلا you are facing your palm and the fingers are going to your eyes, so it is a point for the second wire. Since they have the same magnitude ILB sine 90 for each, ILB not sine 90. In this problem, the angle between the current I and B هي 60 degrees. So ILB 64 sine 60 for each. And but they are opposing each other in magnitude, that in direction. That's why F resultant will be 0. Well, in this problem, we are only interested in the orange rod that is mobile. It can slide on the rails, blue rails. Now we do have forces that we are not representing here اللي هن الويت والnormal, but their projection on the acceleration direction is not important لأنه their projection is 0. So please neglect the weight and the normal لأنه they would cancel out. The only force that is interesting for me here is the direction of the magnetic force. So again, before starting any calculation, you can see on the figure, focus, you have the current and the magnetic field. So we do have a force, a magnetic force. Since the current is going down on the orange rod and B is pointing up, the force F, if you do the right hand rule, is going to the left. So you can imagine the orange rod is moving to the left. Now, the problem is all the constants are given. The mass of the orange rod is given, the length of the orange rod is given, and they are saying if the magnetic field is given 56.3 millitesla at time zero, the device G, the generator, electrical generator, is connected to the rails, producing a constant current given in the wire. And at time 61.1 milliseconds, what are the wire's speed and the direction of motion? Well, actually, we already said that the direction is to the left. Now let's focus on the speed. How are the force and the speed related? Please put pause and think about the right hand rule and try to find the direction of the magnetic force. Well, actually, the magnetic force, sum of forces, if you project them on the acceleration direction, the only force going with the acceleration هي الأف magnetic لأنه مثل ما قلنا الويت والnormal are cancelling each other. So I can say that the acceleration is equal to the magnetic force divided by the mass, and the second law of Newton. And remember, since A is a constant, لأنه الF magnetic is constant والmass is constant, we do say that A is constant, it's not zero. يعني هيدا uniformly accelerated motion, يعني the velocity is not constant, but it is proportional to the acceleration A. Since نحن we are assuming إنه initially the rod was at rest, once you plug in the generator, it will start to move, so it is equals to AT. ما في plus بزيرو. Okay, ال A بعرفها هي FB over M times the time given in the given part A. خلص هلا هون صارت هيني you plug in the numbers and you can find your speed, which is 3.34 10 minus 2 meters per second. But think what's important is to remember the formula of the magnetic force اللي هي ILB sin theta. I is the current, L هي length of the orange rod only. I don't care about the blue dimensions. Okay, أنا بيهمني بس قد طولها للأورنج that is moving. Okay, and then I need the magnitude of the B. And since the current I and B are perpendicular, so sin theta is 1 لأنه sin 90 degrees. And the rest is very easy. Please do respect the units, convert everything to SI unit. So the mass is in kilograms, the time is in seconds, etc.